Okay, hey guys, so I wanted to really quickly show you guys how to name a transition metal. Okay, so when you're going from a formula to the name, you always want to make sure that you do have a transition metal. So remember that transition metals, because their charges aren't always the same, we're going to need to have a Roman numeral to represent that charge. Okay, so what I showed you guys in your notes was you are going to do the reverse of crisscross. Okay, so in this case, your subscripts, so we have an invisible one here, so your subscripts are going to become the charges for the opposite element, right? So hopefully this will start clearing up. Hopefully. Okay, can y'all see that a little bit? Okay, so Pb, okay, is now going to have a charge of +2, and then oxygen is going to have a charge of -1. But you have to make sure that your anion is correct, because our anions never change. Our nonmetals, they are always going to have the same charge. So does oxygen really have a -1 charge? Well, let's take a look at our periodic table. Oxygen has a -2 charge. Okay, so we know that our charges are actually not correct here. So because they're not correct, we need to multiply both charges, okay, so that our anion has the correct charge. So since it's -1, we need to multiply it by 2, so that way oxygen can have the correct charge. So now our new charges are going to be 2 negative and 2 positive, or sorry, 4 positive. 4 positive. Okay, so the name of my my compound will be lead 4 oxide. Okay, but I wanted to show you guys a different method of determining the name of your transition metal if you have a formula. Okay, so let's go ahead and take a look at CO, so that's cobalt, and P, which is phosphorus. Okay, so instead of doing this mess right here, if you're not really good at math, there's a different way to do it. Okay, so you need to ask yourself, well, how many cobalts do you have? Okay, I have 1. And then how many phosphoruses do you have? You have 1 phosphorus, right? So this is your cation, and this is your anion. Okay, so what is your usual charge for phosphorus? So let's take a look at our periodic table. So phosphorus is right here, so it's atomic number 15 in group 5A. So it's going to have a charge of -3. Okay, so phosphorus has a charge of -3. Now, remember as a rule that our charges have to balance each other out, or they have to zero each other out. So if this is -3, then our cation, or our transition metal, must equal what? Okay, so -3 to equal 0, this charge needs to be +3. Okay, so the name of your transition metal or your compound is therefore cobalt 3, and then P is phosphide. Okay, so let's go ahead and try this method one more time. So we're going to write our cation and our anion. Okay, so our cation is Cu. And then we don't know the charge, so our anion is oxygen. Okay, and how many oxygens do we have? We only have 1. So what's the charge for oxygen? That's -2. Okay, so copper's charge must equal oxygen's. So copper has to be +2. So our charge balances each other out and it equals 0. Okay, so therefore the name of our compound is copper 2 oxide. Okay, so we can also do this same way for PbO2, just so that way you guys can get a visual. So if I were doing PbO2, well, your cation, and then what's your anion? So your cation is Pb, and how many do you have? You only have one Pb. And then how many oxygens do you have? How many anions do you have? Well, you have 2 oxygens. So there's one oxygen, and then there's another oxygen. And then again, what are your charges for each oxygen? Well, oxygen has a -2 charge. So your total charge here is 4 negative. So what must be your charge for lead? So it needs to equal 0, so your charge is +4 for lead. Okay, which you get the same answer, right? Lead 4 oxide, which is what we have here. Okay, so if you're really good at math and this makes sense to you, okay, go ahead and use this. But don't forget, you always have to double check your anion's charge. Is oxygen really -1? If it's not, then it must mean that they simplified this. Because remember, if you can simplify a formula, then you have to reduce it. Okay, so the reason why we're multiplying it by 2 is because we're trying to find out what the original charges were. Okay, so either way, if you like doing the math way, do it this way, just be careful. Okay, but this way is definitely a lot easier because you guys can visualize, okay, I have 2 oxygens, and each of those oxygens have a charge of -4. So if this side is -4, then my cations have to equal, or must be the opposite of that. So if this is -4, this has to be +4. If phosphorus is -3, then cobalt must be +3. Okay, if oxygen is -2, copper must also be +2. Okay, so hopefully that helped you guys name transition metals better. Don't forget, you have 3 exceptions to the rule. So you have silver, cadmium, and zinc. Okay, these 3 are the exception to your Roman numeral rule. They don't need Roman numerals because their charges don't change. They will always be the same. Okay, so on your periodic table, I have a little trick for you guys to see for those exceptions. Okay, so you have silver right here. Okay, so that is and then you also have cadmium right here, and you have zinc right here. So they are all next to each other. Now I want you to take a look at your B group. Okay, silver is in 1B, so that means your charge is going to be a +1. Zinc and cadmium are in group 2B, so they have a +2 charge. Okay, and this only applies to just these 3 exceptions. Okay, and then again, your transition metals underneath the ladder, it's gallium, indium, thallium, tin, lead, and bismuth. Okay, so aluminum, germanium, antimony, and polonium, these 4 are considered metalloids. Okay, so they're kind of a nonmetal, kind of a metal. Okay, so they're kind of in between. Okay, so again, it's starting from gallium down, tin down, and then bismuth. Okay, so if you have any questions, please just let me know. I hope this helped you. Okay, and just ask if you have any questions.